This is my video lesson on how to write section 4 of your paper. Section 4 is the hardest and the longest part of your research paper because you're going to be incorporating all of the New York rocks and sediments into the middle section of your paper. So let's start with opening up the daily guide. And section 4 of the paper, you guys can see the due date here. I'm going to open up the guide for day 4, for the section 4, and I want you to take a few minutes and to read through this here. So this whole section is about the Acadian orogeny in Avalon, all the way up through the Catskill Delta, which would have formed when the Acadian Mountains erode into the basin. This is also where you're going to incorporate all the rocks you saw on the trip. For Battaglia classes, you do not have to do the 2 layers of rock that we did not see on the trip, which is the Hamilton Shales and the Scunnamunk and Catskill. That's for Miss Nichols' class only. This section in your paper is going to be 1.5 to 2 pages long with all the photos and captions. And basically what this section is, so I'm going to go to section 4 of my paper. You're writing it in underneath this part here, where you're discussing the Acadian orogeny, the warm shallow sea in New York, the Catskill Delta. Just a snapshot of where we are in your kind of geology story. If you refer to your block diagrams, you finish section 3 with the erosion of the Taconic Mountains. So the Taconic Mountains erode, and the sediments form the Queenston Delta in this sea that is in New York in the Appalachian Basin. If you look on the other side of this block diagram, while all that is happening, you have another chain of volcanoes, Avalon, which is going to make the rest of Massachusetts. This is getting pushed into PNA, similar as to TIA, as Africa is slowly approaching. So in the next block diagram, you can see Avalon is approaching. The ocean floor of the Iapetus is continuing to subduct, and the Acadian orogeny has begun. So your story essentially starts with the approach of Avalon towards Proto-North America, and then the collision. So you're going to have to tell me a little bit about the plate tectonics between Avalon, Africa, the Iapetus Ocean, and Proto-North America. You want to talk about the mountains that would have formed, the Acadian mountains that would have formed in Proto-North America as a result of the collision. So you can see it in block number 41 and also in block number 42. The hard part about this is you also have to think about what is happening in the sea that is in New York at this time and as a result of this collision. So you have to remember at this time with this collision, what is occurring as Avalon approaches and crumples up the land in Massachusetts. What does it do in relationship to this basin here? So you may remember me drawing a diagram where I illustrated kind of mountains getting crumpled up in one area and what happens to the land in the other area gets crumpled down. So you have to try to make a connection between the plate tectonics and this changing of the Appalachian Basin and the changing of the sea levels here. Remember a couple of key points. When there's mountain building and there's not much erosion, the seas in this tropical sea would have had very clear water, like you see in this picture here. And clear water we know is a key to for limestone formation. So you have to think about your New York rocks at this point and kind of which types of rocks would form when there's not a lot of erosion happening in the Appalachian Basin. So the Appalachian Basin would have looked like the bottom picture here when the Acadian orogeny and these Acadian mountains you can see in this picture are forming. So connect your New York rocks to that. The other block diagram you have to go down to is then block number 43. This is the last block diagram where you will see the tropical sea in New York. So in this one here, the title of it is Erosion Deposition of the Catskill Delta. So after the mountain building kind of slows down, you get the sediments getting deposited into the sea, changing the color and properties of the sea water, which would then change the sediments and deposit different types of sedimentary rocks into that sea here. So the last part of your section 4 is kind of writing about the erosion and deposition of the Catskill Delta. So in the meantime, what you have to do here is We did not see evidence of the Acadian orogeny on our trip. However, you guys know that the evidence is basically the rock we're standing on. So basically all of Massachusetts to the east of the Berkshires, including Worcester, Wayland, and Boston, is all formed as a result of the Acadian orogeny. So that would be your evidence. The hard part here is you have to now incorporate your New York rocks into the rest of your New York rocks into your section 4. So you did the Schenectady Formation. Okay, so what you'll be doing from here on in is you'll be incorporating the rest of the New York rocks you saw on the trip. So there's the roundout limestone, which is this thin layer of rock that is in the cliff right here. You have the upper and lower Manlius layers of limestone, which is at the cliff at John Boyd Thatcher. You have the Coymans limestone, which is at the cliff. So these rocks here are all rocks that are at JBT Park, so Thatcher Park. I'm just going to abbreviate it, JBT Park. Those are your layers of limestone, and then your Schenectady is at the bottom. Remember law of superposition, how these would form if you have horizontal layers of rock. The other rocks I need to see in section 4 and kind of in the correct place and how they formed based on the conditions in the sea would be the Oriskany sandstone. This is where you guys collected fossils. And also the Onondaga limestone. So this layer is the cave. So the Onondaga is the cave, and that's limestone. The Oriskany is not limestone, it's actually sandstone as well. So you're going to have to include your descriptions from your field guide and the sediments reading on how those were to form. So you got to, the hard part here is connecting kind of what you see in the present day. So this is present day New York here, and the rock formations that we see to what happens in the past in terms of the pictures here, the basin and the Acadian orogeny, the conditions in the sea. So total will be 1.5 to 2 pages for this section.